But then there's also kind of the long-term warming trend that is kind of hard to ignore now. And there's been a lot of work to model this from very constant CO2 levels all the way up to this higher growth A2 scenario, which if you guys have been reading the news lately, it's now looking like we're even higher than that. So there's a very good chance, and I think at this point almost everyone agrees, that we're going to have pretty dramatic warming, and being able to understand how that's going to affect ecosystems all the way up to top predators, I think is going to become even more of a needed role. At the same time, I don't want to forget space, because these things are obviously very closely linked, and this is a paper from Kenny et al. Focusing on the East Coast with northern right whales, but it really gets at this idea that the animals are using their environment at multiple scales as well. So this example is for migration, where they're swimming down from the coast of Florida for the breeding grounds up to the foraging grounds. They have to use some signals, whether it's bathymetric features or oceanographic features, to figure out the best way to make this migration. But then you have kind of the seasonal foraging ground scale. They have some either previous knowledge as to where they're going to go from where they were raised going, or they use, again, some of these oceanographic features to figure out where the best spot to go is. But they usually can figure out in the broad area how to get back to these foraging grounds. And then, again, using both oceanographic and social cues, can cue into individual or kind of broader scale patches of prey, kind of the 1 to 10 kilometer scale shown here. But then, as the individual feeding events happen really on the meters, so they're using other cues. Now they're getting into visual or sensory cues to get an idea for where the biggest aggregations are and how best to feed upon them. And so these, like, as I mentioned, these two things, both the space and time, are pretty inextricably linked, unfortunately, for us. But then how are these climate signals affecting marine mammals specifically? I'm going to kind of focus on long-term trends, but there's obviously this direct effect. There's just increased temperature or decreased temperature is going to have physiological constraints, but for warm-blooded animals, that's obviously less of a concern than for maybe some small fish or things like they can't move like corals. But at the same time, there's a lot of indirect kind of food web effects, and these have been shown whether it's sea lion declines during El Nino years, or if it's just changes in distribution of animals like Karen Forney is going to be talking about later, as a function of this environmental variability. The environment does have more of a direct role on the prey, which then, in many cases, can drive distributions of the predators as well. But this is also getting a little bit too, I should have mentioned, this is getting a little bit into kind of my research focus, is how do these top predators use both the environment and prey to forage? Are they using the environment as a roadmap to get to the prey and then foraging, once they see the aggregations, or is it more linked and more social factors? And then the fourth point is, as I mentioned, how might these top predator distributions change in the future? So one of the projects I've been working on is using global climate change models and the top data set, which has tag data from elephant seals, California sea lions, and blue whales, in addition to other predators, and maps essentially how kind of habitat preferences might change out to 2100. And for the example here, 2 out of 3 species, the elephant seals and the blue whales, are actually showing a decline in kind of core habitat, and the habitat that they prefer to either travel to or forage in. And so there's some concern that in addition to all the other stresses that we have upon the ecosystems, this long-term climate signal might just be one more that we're going to have to worry about. And so this is a plot from Hal Pernodal's 2009 science paper, where there's another follow-up where he looked at the California current and shows just climate in the top right, but in addition to fishing, threats, and other. And it's going to be more and more necessary, especially with this changing environment, that we take as many of these into account as we can.